Hello everyone, I am Aayushi and I am a PhD student at Northeastern University, and today I am here to talk about leveraging transparent checkpointing for fault tolerance in RISC-V. So let's first begin with some background information about RISC-V. And so it's an open source implementation of reduced instruction set computing, and which is it's an instruction set architecture. And basically, as mentioned, we have RISC-1, 2, 3, 4, and then RISC-V. These all were significant steps in development for RISC, and each iteration brought improvements in terms of performance, efficiency, and complexity. RISC-V has been designed to be modular and extensible, and this modularity enables various applications and hardware platforms, and also the creation of specialized processor cores for different or specific tasks. Most of the ISAs like x86, ARM, Spark, they all are commercially patent, but this is open source, so it provides a great community and opportunity to be more creative with it. So, cursor, I can't see it. Okay, so why there is a need of middleware development? So, I would say as RISC-V is continued to expand, the software stack is getting complicated, and it leads to the necessity for development of various middleware components. So these middleware components would act as a glue to hold together various elements of complex RISC-V and give us critical functionalities like fault tolerance, security, virtualization, and many more. Fault tolerance, I would say, it's kind of a safety net for you, and it enables to continue operation possibly at a reduced level rather than failing completely when some part of your system fails. So middleware like transparent checkpointing plays a pivotal role in achieving fault tolerance, and that's somewhat we did for this particular project. So again, so next I'll just dive into DMTCP checkpointing and how we integrated DMTCP with RISC-V to achieve transparent checkpointing in RISC-V. So let's first dive into what is actually checkpointing. So checkpointing, it's an action of saving state of a running process to a checkpoint file, or in a simple word, I can say it's just snapshot of an application state, allowing application to restart from the point of failure. It can be used in various scenarios, like if a process crashes, then roll back to the previous checkpoint, ensuring continuity and fault tolerance. Or what if you are running a long job and which takes 72 hours to process, and it's time to go home and have dinner. So you can just checkpoint and restart it next day and ensure extended sessions. Also, it's very useful in resolution of bugs or program development, as you can just checkpoint after every 30 seconds, and if the process crashes, you can send that checkpoint image to the developers to reproduce the bug and even resolve it. So in order to provide middleware support to RISC-V, I tend to choose transparent checkpointing, and particularly for transparent checkpointed, I lean toward DMTCP, which is an open source package. So I would just like to convince you why I chose DMTCP. So, okay, what is DMTCP? DMTCP stands for a distributed multi-threaded checkpointing. It is an open source package which is which is available for all major Linux distributions, and it supports dynamic compressions for checkpointing, forked checkpointing, on-demand paging for fast restart. Among the applications supported by DMTCP are MPI, OpenMP, MATLAB, Python, Perl, many programming languages, and shell scripting languages. It's very easy to use, as you will see in upcoming demo. And this project is in its second decade, and more than 50 other groups have been using their published its published literature. And I've also attached some numbers for you, downloaded numbers for you to see. Yeah, it's very popular among the community. So let's get an idea about basic idea about how DMTCP work, and then I can just go over the demo that how I ran it on the RISC-V. So basically what we have is DMTCP has a central coordinator. As soon as a process starts up, it immediately preloads its library. This library primarily does two things. It creates a checkpoint thread that you can see and starts a connection to the coordinator. At any given time, either the checkpoint thread is active or the user thread is active, not both. And when it's time to checkpoint, the checkpoint thread comes along, sends signal to the user, they go into DMTCP's signal handler, and they get blocked. So that's the basic architecture of DMTCP. Now that we have an understanding of the working and the architecture of DMTCP, let's talk about how we ported it to RISC-V, and what were the changes made, what were the challenges faced. I think before that I would like to show you a demo. Okay, so let me tell you what was the setup. So for hardware, I used Beagle 5 Fire board, which is a low powered board, and it has microchip polar fire 5-core RISC-V system on chip with FPGA fabric. It was preloaded with Ubuntu 20 Linux operating system, and despite of my full-time PhD, I was able to successfully port DMTCP to RISC-V within 2 weeks. So yeah, porting any middleware, I feel porting some middleware to RISC-V is feasible and efficient if done correctly. So yeah, this is the setup and time that I took. So okay, let me just show you one demo that is, oh god. So this is a simple code that I'm testing on RISC-V. It's just a code that will run till infinity, and what I did is I checkpointed it after 5 seconds, and it will save the checkpoint image, and when we restart with that checkpoint image, it will restart from the particular point that I stopped. So I'll just fast forward it. Yeah. So as you can see, it's DMTCP is very easy to use. It's just these two commands to checkpoint and run that particular checkpoint image, and yeah, as you can see, it started from 7. So yeah, checkpointing and DMTCP is working on RISC-V. I have another demo that is showing, okay, that shows okay. So this demo is basically a C++ program that establishes communication link between more than one processes using TCP/IP sockets. And okay, so there is not that much interesting to see anything here, but yeah, it passes the test cases and shows that okay, this C++ code is also running and successfully checkpointing and restarting from the checkpoint image. Okay, so yeah. Okay, so let's talk about what were the changes that I made in DMTCP, particularly to support it on RISC-V. So when porting DMTCP to different architecture, the main focus lies on adjusting MTCP, that is the core component responsible for checkpoint and restart. The CPU specific code segments can often be identified by just searching ARM on the code base, and you can see there were just only like 20 lines of inline assembly code that we need to change to support RISC-V. However, RISC-V, on RISC-V there is a notable difference in how thread local pointer registers behave compared to other architectures. It points to the end of the TCB rather than the beginning, and this requires a specific adjustment in MTCP's logic when updating process IDs and thread IDs during restart, and before adding an offset to locate the storage of PID and TIDs, we have to subtract the size of P thread structure from the thread registers. So these were the, I would say, major changes that I have to made in existing code of DMTCP to support it on RISC-V. I was more interested in the challenges to share with you. So one major challenge that I faced was lack of DWCAS. So what is DWCAS? It's double word compare and swap. It's an instruction that is not supported on RISC-V, and it is commonly used to implement log-free data structures and is particularly useful in concurrent programming scenarios and low latency special purpose allocators used by DMTCP. So basically it is an atomic instruction used in multi-threading to achieve synchronization. It compares the contents of a memory location with a given value, and if they are not, if they are same, modifies the content of the memory location to give to a new given value, and it is done all in a single atomic operation. In concurrent programming, DWCAS is essential because alternative of DWCAS, that is mutexes, would make execution too slow when running many threads. So current alternative that I took to port DMTCP in lack of DWCAS is to make direct call to malloc, which is ultimately slower. So that's the thing. So I would, like we have expert on RISC-V, I would like to ask this question, like will future RISC-V architecture support DWCAS, because that would make things simpler and quicker, I would say. Another big challenge that I faced was related to hardware. So I used Beagle 5 board. It is very low powered board with 2 GB memory. That makes processing really slow. Like I was running debugging under GDB, and sometimes there was no response for 2 minutes, and that's really slow in the era when we are just skipping 10 seconds video. So that was really slow. Finally, support for pthreads is little tricky. We are currently working on this. Currently, pthread create is able to create multiple threads. It is working, but at the time of join, parent process seg faults even before child finishes execution. This can be fixed. Work is still going on, so hopefully we would be able to run multi-threaded programs also on using DMTCP on RISC-V. So yeah, that's it. I hope this gives some motivation to port other interesting middlewares to RISC-V and give support on RISC-V. Yeah, that's it. Open for questions.
This may be a question of terminology. I'm a little puzzled because when you say DWCAS, in the RISC-V terminology, a double word is 64 bits.
Yeah.
And in RV64, you can do a 64-bit AMO. Are you running on RV32 and therefore you don't have it? Or I didn't quite understand when you said it's not available on RISC-V, because there's an AMO swap instruction in RISC-V's ISA, which can do a 64-bit swap on RV64 systems. So I'm puzzled when you said it's not available.
So yes, I think it's on 32-bit because.
Yeah, it won't be available on a 32-bit machine.
No, but okay. So when I tried using DWCAS, I was not able to perform the particular instruction, and then I go through the instruction manual of the RISC-V, and I didn't
I see.
yeah, see any kind of support for
Maybe we'll talk offline.
yeah, sure. So yeah.
Other suggestion I was going to say is it's not only useful for the purposes you described, but as somebody who's designing RISC-V cores, one of the things you do is try to boot Linux in simulation, which can take hours.
Yes.
And this could be a great help to checkpoint things and restart quickly, simulations and so on. So.
Yes. Yeah. Yeah.
Yeah, honestly, it sounds extremely useful. I didn't know about this. Any more questions? Oh, there was one.
Just a brief comment. Yeah, the history of DMTCP extends more than 10 years earlier, and there's also been a collaboration with Intel previously doing exactly this, using simulations in order to checkpoint in the middle and then restart. Thank you.
Right then, no more questions.
So I'll be here till lunch today, and because I'm flying to India tomorrow, so I would not be here after that. But we also have Jean here, who is, like I would say, primarily developer of DMTCP. So if any questions, just you can just ask us during the lunch or after that. Yeah.
Thank you. Let's thank the speaker again.